Hi, in this video we are going to look at the integral solutions based questions from the topic permutation and combinations. The questions will be of this type. In this question we are asked to find the number of integral solutions to this equation. Given equation is a plus b equals to 9 and it is written that a and b are lying can be any value from 1 to 6. Now this question, if you see, because the a values are lying from 1 to 6, in between 1 to 6 or including 1 and 6, this is similar to find the number of ways in which the sum of the digits on the two dice when it is 6. This question is 9. So this is a plus b equals to 9, so that's why it is 9. Why it is similar to this? Because when we roll dices, we are going to get any digit from 1 to 6. So that is why these two questions are similar. Now, in the earlier video, I have introduced this concept. So we'll start solving this. So this is a plus b equals to 9 and a is lying, a and b are from, you can take the values from 1 to 6, and moreover we are asked to find the number of integral solutions to this. That means we are looking at finding out natural number solutions to this equation. Natural number solutions to this equation, because a and b are starting from 1. Had it been a and b are starting from 0, then it would have been whole number solution. So we are looking at natural number solutions to this equation. So here it is 9. There will be 8 gaps. Out of 8 gaps I will select 1 because there are 2 variables, so I will have to select 1 gap. This will give me the total number of integral solutions to this equation, provided a and b are lying from 1 to 6. And moreover, the problem with this solution is 8 plus 1 equal to 9. This is also included, but our condition says that a and b should lie between 1 and 6. So we need to subtract the cases where they are more than 6. So if a is 7 and b is equals to 2, this is one possibility. This will lead to 2 ways, because this is a and this is b, they can be interchanged. Next comes 8 and 1. This will again be 2 ways. So out of 8c1 we need to subtract these 4 ways. So we will finally get the integral solutions to the equation a plus b equals to 9, provided a and b are lying from, can take a value from 1 to 6, inclusive of 1 and 6 both. Now first, initially we are finding out the total. In this step, this solution includes 2 steps. Step 1 is finding out the solutions, and then step 2 is eliminating some of the cases where the condition given in the question is not satisfied. Now instead of solving this question in this way, what we can do is, here we were listing out the cases when a was greater than 6 or else when b was greater than 6, and then we were subtracting. So instead of listing down these cases where a is greater than 6 or b is greater than 6, what we can do is we can simply substitute a. Assume that a is greater than 6. Say a is 6 plus some x, and x should be greater than 1, because it cannot be greater than or equal to 0, because if it is 0, a is equals to 6, it will still be a valid case. We need not subtract that particular case. So that's why what we'll do is, instead of a, we'll put simply 6 plus x plus b is equals to 9. x plus b is equals to 3, and x comma b are greater than or equal to 1. So the solution would be, there will be two gaps. I'll select one out of two gaps. It will be 2c1. Now this thing we have done for when a was more than 6. Now similarly b can also be more than 6. So whatever we get 2c1 when a was more than 6, we need to multiply it with 2, because there are two variables, that is a and b. So directly we can get this 4 can directly be obtained instead of listing down the cases. Here the number is 9, then we were able to list down, then we were able to list down easily. But if it is more than 9, and if there are 3 dice that are rolled, in those cases it will be very difficult for us to list down these cases. We may make an error. So instead, in order to avoid that listing down all this process, what we have assumed is, we have taken a to be greater than 6, some value. So we have put a as 6 plus x. So we have substituted that value of a, and then we have got this equation a plus x plus b is equals to 3, and we already know that x and b are greater than or equal to 1. The number of integral or natural number solutions to this equation will be 2c1. And similar thing, b can also be greater than 6. Say b can be put as, we can put b as 6 plus y. We are again going to get this 2c1. So that's why I have multiplied it with 2 and got 4. Now we will look at another question. It will be clearer to you. Now in this question, we are given this equation a plus b equals to 11, and a and b are lying from 1 to 6, and we are asked to find the number of integral solutions to this equation. This is again similar to the number of ways in which the sum is equals to 11 when two dice are rolled. So this is similar to that dice question. So because a and b are again lying from 1 to 6. Now here, if we go by the traditional way, total number of integral solutions to this equation, provided a and b are greater than or equal to 1, are, there will be 10 gaps. Out of 10 I need to select 1, because there are two variables. So this is 10c1 will give the total number of integral solutions to this equation, provided a and b are greater than or equal to 1. Now here, but the upper limit is a and b should be less than or equal to 6. So there will be cases. For example, if it is 7, there would be 4. 7 plus 4 will be 11, and 4 comma 7, this is again arranged in two ways. So next, if it is 8, here it is 3 comma 8. Then again here it is 9, it is 2, then it is 2 comma 9. If it is 10, here it is 1 over here. Next here it is 1 comma 10. So these are all the 8 cases that needs to be subtracted. Now instead of subtracting these 8 cases, what we can do is simply put a as some 6 plus x when a is greater than 6, and substitute it in that equation. This would be 6 plus b is equals to 11. So x plus b, and here x is greater than or equal to 1. X plus b is equals to 5. 5 means there are 4 gaps. I'll select one gap because there are two variables, and multiply it with 2. So finally we are going to get the same 8. So what we have avoided is listing down all these cases when a is more than, a or b are more than 6. Now let us look at another question. Now this is the next question. Here 3 dice are rolled, and the sum is 10, and the a comma b comma c are again lying between 1 to 6. We need to find the number of integral solutions to this particular equation a plus b plus c is equals to 10. So traditional method, the total number of integral solutions when a comma b comma c are greater than or equal to 1 will be, there will be 9 gaps. Out of 9 I will select 2, because there are 3 variables here. Now instead of listing down all the cases, what we can simply do is put a as some 6 plus x in that equation. X is greater than or equal to 1. So here this would be 6 plus x plus b plus c is equals to 10. X plus b plus c is equals to 4. There are 4 balls, so there will be 3 gaps. Out of 3 I will select 2, and there are 3 variables. Again I will multiply it with 3. So total number of integral solutions to this equation when a and b are lying between 1 to 6 is 9c2 minus 3c2 into 3. We have not listed down any cases. We have directly got the answer. Now let us look at another question. In this question, it is a plus b plus c plus d is equals to 13. 4 dice are rolled and the summation is 13, and a comma b comma c comma d are all lying between 1 to 6. It is lying between are from 1 to 6. So the total number of integral solutions to this equation would be, so there will be 12 balls, out of which I will select 3 balls because there are 12 gaps there will be there. I will select 3. So this is 12c3 minus the cases where a comma b comma c comma d are greater than 6. So instead of listing down all those cases, what I'll do is simply substitute a with x plus 6, and this will become b plus c plus d is equals to 13. So this is x plus b plus c plus d is equals to 7. 7 means there will be 6 gaps, so 4 variables are there. I will select any 3, and then because 4 variables are there, I will multiply it with 4. So this is the final answer, 12c3 minus 6c3 into 4. So this is the next question. Here 5 dice are rolled and the summation of the digits on those dice should be equal to 12, and a1 to a5 are lying from 1 to 6. We are asked to find the integral solutions to this equation when a1 to a5 are lying from 1 to 6. So integral solutions to this equation would be when a1 comma a2 comma a3 comma a4 comma a5 are greater than or equal to 1 would be, there would be 11 gaps. Out of 11 I need to select 4 because 5 variables are there, and subtract the cases where these variables are greater than 6. So what I'll do is I'll put a1 as x plus 6 and substitute in that equation. a2 plus a3 plus a4 plus a5 is equals to 12. So this is x plus a2 plus a3 plus a4 plus a5 is equals to 6. So 6 means there will be 5 gaps, out of which I need to select 4, and there are 5 variables, so I will multiply it with 5. So this is 5c4 into 5. This will be the answer.